Hey everyone, today we're gonna be doing a Leetcode question which is height checker. So in the problem statement they are saying a school is trying to create an annual photo of all the students. The students are asked to stand in a single line, or you can say they are asked to stand in a non-decreasing order. It means like every student should come as like smallest to largest in an increasing order. Also, they are saying let's this ordering be represented by an array expected. They're saying like you need to create some expected array where every element in that expected array represent the height of the student. What they're saying like you are given some integer array heights, which is the actual height, in such a way like every student in this height array represents the height of a student, and they are saying like this height array represent how the students are standing currently. So what we need to find out, like they are saying like how many students are standing in a wrong order. So they are saying okay, return the number of indexes where the height of a student is not expected. Like they're saying like this is the current height, you can say this is the current order in which every student is standing as per their current height. They're saying like what should be the expected height of a student, like where that particular student should stand. So let me like explain with some example. So let's take the first example. So what I'll say like okay, we are given what, we are given some height array. So I'll say okay, this is our height array, and this is like 1 1 4 2 1 and 3. So this is what, this is we are given the height array. What we need to find, like we need to find the expected array. Expected array means it should be coming in the increasing order. So if I say, if I create the expected array, okay, so if the expected array created from this one, so it will be like the sorted one, 1 1 1 2 3 and 4. So what they are saying like okay, just find out how many students are like standing in their wrong area. So if I say okay, this index 0 1 2 3 4 and 5, similarly 0 1 2 3 4 and 5. So if you see like this particular element, you can say this particular student is not like currently standing in their original position. Similarly for this one, similarly for this one. So if I write in like in a same line, or let me create like this is the original height at which a student is standing currently, and what should be the expected, they are saying it should be in an increasing order. So this will be the increasing order, the height should be like coming in this format. Okay, so what we have, like this is one height, this is another height. So if I say we have one height is like this, okay, another height we have like this. What they are saying, this particular student should come somewhere else. So this is not a correct expected height, this is not as per the requirement. So this is one bad student, this is one bad student, this is one bad student. So if I say okay, what was this, this was the original height currently student is standing. Okay, this was what we are expected to make student stand like this one. So if you see, we need to find the count of how many students are not standing at their actual position. So this is one position, this is one position, this is one position. So the, you can say the very first or the basic idea, what we can say, we have this height array. What we can do, we can do this sorting, like we have done this sorting already. So what we are saying like okay, you have the height array, create a new array as a sorted array, and just compare each element how many are not aligned with their original position. So this is having height 1, this is also having height 1, this is also having height 1, so these are fine. Now in the original height array, in the second position, or you can say second index, the 4 height student is coming. But if you say, if all the students are asked to stand in a sorted array, or you can say increasing, like increasing way, so this should not come here, this is correct, and this also should not come here, this also should not come here. So what is the basic brute force idea, we can do the sorting and we can do the comparison. So if I say for sorting, if I say for the sorting so time complexity for sorting will be n log n. Okay, this is for what, sorting. And similarly after sorting we need to iterate, so it will be like order of n. Similarly, the space complexity will be what? Order of n, because we are storing the height, or you can say height of the student again in some array. Now we can also do some optimization in this, like if you see in the question, if I say this is our question here, and it is given you have the constant like height can go till maximum 1 to 100. So we can like we can take some help of a counting sort. What we can do, we can create you can say frequency or the counting of particular student. So they are saying like student can go from 1 to 100, like height of the student can go from 1 to 100. Similarly, the number of student also can go from 1 to 100. Okay, so these are some constant. What we can do, we can create some expected height array here. If you see, we have done the sorting and we have got the expected height in which a student should stand. But for this, we are required to use the time complexity and log n. Okay, we need to reduce this to some extent. So what we can do, we can use the counting order, because in if we want something in an increasing order, and the height is like from 1 to 100, what we can do, like we can store the occurrences or the frequency of this many heighted student, and we can iterate again from 1 to 100. So what I'm saying, like we can create an array, like we can create an expected array. We can say like we have our height array, something like this: 1 1 4 2 1 and 3. What we can say, I can create some like expected array. Expected array, how I can have the frequency as 0, and how many element I required? I required like 100 element. So indexing start from 0, so I'll take 101 element. So I do not need to do the offset. What I can do, like for every element, like for every student in this height array, what I'll say, okay, I'll increase the count, or you can say occurrences of this particular height. So I'll say okay, expected height plus plus. If I found the this particular height, I'll say okay, I'll iterate over this height array. I'll increase the frequency of this particular height in this array, expected array, because I have fixed amount of height 1 to 100. So what I'll say, okay, I'll iterate over this array. I'll increase my frequency. So at last, what I'll be having, like I have one coming like thrice, I have 2 coming once, I have 3 coming once, I have 4 coming once, and it will be starting from 0 to 100. Okay, 100. So I need to store all the frequency, and again I will be iterating over this array, and I will be like creating a new array. Like I'll say okay, 1 came how many times? I have the resultant array. It will be like if I say okay, resultant array will be like this: 1 came how many time? 3 time. 1 1 1. Again 2 came how many time? 1 time. 3 came how many time? 1 time. 4 came 1 time. So now what we required, like this is our expected array. What we want? The sorted array. We can say here, if I say this is 1 1 1 3 2 3 4. Similarly, we got this one here: 1 1 1 2 3 4. Now we need to compare this one. Is it okay? Yeah. Is it okay? Yeah. So if I say this particular element, this and this is not equal, this and this is not equal, this and this is not equal. Now we have created this particular array using order of n. Like we have taken the order of n time complexity for storing the occurrences, again creating the resultant array. So let me do some code and let me show you how will this work. So I have this array. So I'll take the first example, like I'll create the expected array. The very brute force idea, like I'll be taking the sorted array of what? Height. So it will be creating a sorted array of that particular heights. Now I have some size. Let me not use. I'll use some count for now. So I need the count of how many students are standing in a long area. So I'll say okay, for I in range and what? Length of heights. Now I need to check how many heighted array, or you can say how many students are not standing in their actual position. So I'll say okay, height of I does not equals to expected of I. So okay, one more thing, we need the condition. Okay, if this is condition satisfy, like students are not standing at their expected position, I'll say okay, count plus equals to 1, and at last I'll say okay, return what, count. Okay, so let me compile this one and let me show you is this working or not. So they're saying okay, in range, sorry, yeah. So again I'll compile. So it is like checking how many elements are in their correct position. So I'll submit this code. This is a very brute force idea using the sorting. For this we have taken the time complexity. So for this we have taken the time complexity of what, n log n. Okay, n log n. But we need to optimize this part. So we'll not use this one, this logic. I'll create some frequency of a element which will be 0 for now, and I have 101 element because I will be like looping for what, I will be storing the frequency of my element from 1 to 100, but it will be having indexing from 0, so I need to store the element frequency from 1 to 100. Now what I'll do, I'll iterate over this array. So let me come here. I'll say okay, for num you can say height in heights array if, or just simply I'll say frequency of that particular height, and I'll say okay, increase the frequency of this particular height by 1 because we got this particular occurrences once. Now we need to create the resultant array. So I'll say okay, now the expected array, I'll say okay, expected expected array, we have this one. Now we need to create this expected array using these frequencies. So I'll say okay, for I in range what, it will be going from 1 to 100, okay, or 101, because we need to include the 100 as well, because the you can say the constant given, it can go from 1 to 100. So height of the student can go from 1 to 100 inclusively. So I'll say okay, iterate from 1 to 100, and again iterate j, how many times, I'll say okay, in range how many times that particular element came. So I'll say okay, this is our frequency array and the ith element. So I'll say okay, this ith element of the frequency came how many times. I'll say okay, now I need to do what, expected array. I need to say okay, expected array dot append. I mean I need to append the frequency of I. You can say the number came how many times. So I'll say okay, this is like 1 is coming 3 times for this case, 2 is coming 1, 3 is coming 1, 4 is coming 1. So let me compile this code. Rest will be same, like we will be comparing the expected and the resultant array. So let me compile this one. Let me check whether it is working fine or not, and let me submit this code as well. So I'll submit this code, and this is also working fine, and we have reduced the time complexity from order of n to what, for this particular case it came to order of if I say this is order of n plus k. Okay, because we have like how many time particular element is repeated, we are not sure. So we'll say okay, it will be maximum k times. Like we have a range from 1 to 100. It is going from n, like n is going from where, n, you can say n is going from 1 to 100, and we are not sure how many times this will be repeating. So I'll say okay, k times at max it can repeat, so it will go from n to k. So the time complexity, the worst case, or you can say final time complexity will be order of n plus k, and the space complexity is order of n for storing the you can say expected result, because the frequency is fixed, like it's 100, you can say 100 students or 100 height. So yeah, that's all for today. Thanks for watching.